Alrighty, today we'll be talking about negation circuits as well as decoder circuits. Here I have this negate 4 circuit loaded up. I have some exclusive OR gates as well as this adder 4 here. And I loaded this adder 4 here from another project that I had built previously. To load other projects, you go to project here, load library, and Logisim evolution library. You could tell that I have all my circuits here in this folder. Depending on where you save your files, you go up here and look for that. I selected this half adder and I opened it, and here I have it here. So I took this full adder, or excuse me, this adder 4 here, and loaded it into this negate 4. So that's how you load in previous projects. So to show you how this works, let's say if we have an input of -5, this is sign binary here. So we have a -8, a +2, and a +1. And what happens is we get the exact same output here. We have a -5. But if we hit this control circuit, then we get the 2's complement of whatever our input was. So you can see we have -5 here, and now we have +5. All right, so how is this working? We have these exclusive OR gates lined up here. All right, and now the exclusive OR relationship states that anything that is a 0 or a 1 will output a 1. Excuse me, I should say a 0 and a 1 will output a 1. If we have a 0 and a 0, that will output 0. If we have a 1 and a 1, that will output 0 as well. You can see A3 has an input of 1, and this control is adding a 1 as well, so we'll have an output of 0 here in this Q3 output. Now A2 is inputting 0, and this control is inputting 1. Therefore, we'll have S2 output 1. So that's the exclusive OR relationship. Now this A0 here is a little bit different. If you remember, 2's complement is what we would do is take everything to be the exact same up until the first 1. So we'll have an input of 1 here, input of 1 here. We should have an output of 0, but this control is adding a 1 via this C in input here. I could kind of show you maybe a little bit in more detail here. This C input is adding 1 to this A0. So we'll get a 0 there. And if it's 0, it'll be 1. So that keeps things the same for this first input if it happens to be an output of 1 or an input of 1 as it is here. So let's go ahead and show you the decoder. So here I have the decoder, and I'll show you how it works. Say if we have an input of 4, then what we'll get is an output here in Q4 to be turned on. So something that you should notice is that we have everything as 1 except for Q4, which is a 0. And this is because of these NAND gates here. This is known as a active low output decoder. If we were to use AND gates here, then it would be deemed as an active high output decoder. So everything here with 1 would be 0, and this output here, Q4, which has a 0, would be the only one that would have an on. So these are how these decoders work. Everything will be turned off, and for whatever input here you have, will be designated to have only one of these outputs working. Okay, so now with this control here though, what this does is it acts as an on-off switch. So if we turn this on, everything gets a 1 no matter what we have inputted here. Everything just remains to be 1. In our case, turned off. So if we wanted to extend this design to have more inputs, what we would do is take everything to be exactly the same. XYZ inputs would look exactly the same here. What we would copy and paste this whole thing here, and we would assume that this control would act as a W input, for example. And so we'll have a WXYZ 4 inputs, and what we would do is we would take the output of W, and we'll make sure we'll avoid this not here. This would be bad, for example. We go before the NOT gate and have what would be the W input be inserted into another set of 8 outputs, and it would be put into this W out input here for the next set of 8 circuits. So we'll have 4 inputs and then 16 total outputs. So what happens is if you turn this on, then this whole circuit will turn off and the next circuit will turn on, and these next set of 8 outputs will be working. So that's how you would extend this design. So if we wanted to, use this decoder in real life, one example I'd like to think of is, forgetting the name, a vending machine. So for example, vending machines work as, say if you want a certain snack in a certain input or in a certain, position in the vending machine, say it's in position 4, you would hit 4. Let me turn this back on. It would be in position 4, and then everything would not be working except for that one snack that you're wanting. That little spiral thing will start turning and your snack will be given to you. So vending machines are a good example of when decoders are very useful. So that is all, and thank you for watching.